Welcome back to fsharpConf, and we're here with Jeremy, and he's joined us from Portland.
Hey, y'all.
How do you like Portland?
It's actually warmer there today than here. Like, it is super cold.
You chose the best day to come.
Yeah, no joke.
And you're going to be talking about SafeStack.
Yeah, SafeStack 2018.
Yeah.
2018 because I gave a talk similar to this last year, but a lot's changed since then.
Yeah, you gave similar talk at .NET Fringe, I remember, and it was awesome.
Thank you.
Yeah.
And it was warm, so this year we'll be getting warmed up by the awesomeness of the SafeStack because it is super cold.
Yeah. So because there were quite a few changes, we're super looking forward to hear the talk, and I know that there are going to be quite a few live demos.
There will be some live coding. It won't be as amazing as Tomas Maski's live coding, but it will be good.
It will be amazing. Cool. Okay. I'll let you get started.
Cool. Well, thank you, Lena. All right. Hey, y'all. Like Lena said, I'm Jeremy, and we're going to be talking about the SafeStack in 2018. Before we get started, though, I want to give a shout out to Lena and Tomas and Philip for making fsharpConf happen this year. And like I said, I'm on Twitter at Mr. J Abbott, and you can email me here. And I have a blog that I never update. So yeah, we're going to talk about the SafeStack. The SafeStack has everything. So what is it for? It's for functional first full stack development. And we're going to break down what safe actually means, talk about some of the features of the different parts of the stack, and then we're going to do a live coding demo. So to get started at a high level, safe stands for server, Azure, Fable, and Elmish. And so on the server, it used to be called it was just Suave, but in the last year and a half or so, a few things have changed, and we have a lot of options now on the server for writing web apps with F# or web APIs or whatever the case may be. So on the server, we can use either Suave, Draft, or Saturn. We're going to talk a little bit about Suave today, but mostly we're going to focus on Saturn. The ACE, of course, stands for Azure, which we're not going to dig into because that's a whole different conversation. But SafeStack apps can be deployed to Azure or whatever your favorite cloud provider is. Then we're going to dig into Fable and Elmish. One of the cool things about the SafeStack is that it allows you to share code when it's pragmatic to do so. I put that caveat in there because sometimes code reuse can be a bad thing, but we're going to look at some scenarios where code reuse is actually really powerful. And it's F# all the way down, so there's nothing to complain about with that. So why would we do this? One, type safety. If you're doing any sort of client-side code, unless you're using something like TypeScript or some other transpiler, you don't have a lot of type safety. So you have to deal with things like double equals versus triple equals, weird number types, whatever the case may be. As we're going to see through our live coding demos, you can do some really rapid feature development. Like I already said, some practical code reuse. We get to leverage our F# language features on both the client and the server, so pattern matching, algebraic data types, default immutability. I don't have to worry about, again, like other weird JavaScript things like what this means. One of the really cool things about the SafeStack is that it does have commercial support. So you can hit up Lambda Factory or Compositional IT if you do want to get some more advanced professional feedback on how to support the SafeStack in your business. And these slides are going to be posted later, so you can click those links and check them out. One other thing to point out is the SafeStack is actually used as part of the .NET Core daily validation, so that's pretty sweet. And also, while we're talking about web apps today, you can use the SafeStack with React Native, and if you go to the SafeStack GitHub repo, there's an example of that. Cool. So let's dig into what the server side looks like. So server side, F#. You have a few options. These are just some of them. There's Suave, Draft, and Saturn. And we're really going to focus on Suave and Saturn today, but and mostly Saturn in that case too. So in a really basic example, this is what a Saturn app or a Suave app would look like. And we have what's called a web part up here. And it basically is a web part is a function that represents a web request and response. And then you can compose those together to create your entire request pipeline. So in this case, I have a web part that returns a 200 with hello fsharpconf in the body. And then I could actually compose a few web parts together. So if I had like a GET request that went to hello, I would get back that hello fsharpConf. And if I just said a post to goodbye, I would get back a 200 with goodbye in the body. And the key part of how like these web parts work is that they get sort of composed based on like different little pieces of the request. So if I'm doing a GET, I sort of hit this path and then, or this branch, and then if the path is hello, then I would keep going and so on and so forth. And the same for like the post scenario. And then one thing about Suave is it's not just a web application framework, it's also your web server. So I can configure the web server in a lot of different ways. I'm just using the default configuration for this example. But like I just say start web server, I give it this web part, which is the composition of all of the other ones as the last argument, and that kicks off starting my web server. Another framework we're going to talk about is Saturn, which is fairly new on the scene. What I really like about Saturn is that if you're trying to expose like your team to F# and like web development on that stack, you're already going to have maybe some reluctance because if they're not familiar with the language or some of the language features in general. So something like Suave might not be the best way to start, just because not only are they having to deal with like all of the functional programming paradigms, even though F# is a multi-paradigm language, they're also going to start seeing things right away that might scare them, like these custom operators, which are used for composing the web parts. Even though after you get used to it, it's not really a big deal. It's just one more thing that people have to sort of get over. So it's another hurdle to adoption. What I like about Saturn is that Saturn adopts a MVC style architecture for your server side, and it also it can return static views if you want to. We're going to use a SPA style app today, but when you talk to somebody and you're talking about actions and controllers, that's a vocabulary that they're already familiar with from something like ASP.NET Web API, or ASP.NET Core, or whatever the case may be. So what I like about this example is I have an action, and in this case it's just doing the same thing, except I threw a little emoji in there because why not? And then I have a controller which just says for the index path or whatever the case may be, we're going to use the hello action. And then I set up my router. I'm going to forward anything that goes from /hello through that controller. And then I set up my application. And what I really like about this application piece is that it sort of abstracts some of the complexity of just setting up like your iWeb host builder in ASP.NET Core. So, and that's one of the things about Saturn that's really nice, is it uses computation expressions to hide some of that complexity unless you actually need it. Doesn't necessarily prevent you from using it, but it just sort of gives you some really nice abstractions to get the job done. But if I and this is actually true, if you present this as I have at my own, like where I work, this is a lot more user-friendly for somebody who's just getting ready to adopt F#. So these are things that they can reason about in a way that maybe Suave may not be as approachable. And Saturn sits on top of ASP.NET Core and Giraffe. And Giraffe is actually very similar to Suave, except that instead of using its own web server and like application framework, it really is just building on top of ASP.NET Core. So you can take advantage of like Kestrel and everything else in the ASP.NET Core pipeline. And then Saturn just sort of sits on top of those. And like I said, it has some elegant MVC abstractions. Saturn has what are called rings, and we just mentioned those, ASP.NET Core and Giraffe. It also has something called moons, and that's basically other pieces that you really need to write like a full like web application. So you probably need some sort of persistence model, and you need a mechanism for working with that, but you also need to be able to like change that persistence model over time. So it gives you, it hooks into Dapper for database access, and then it uses simple migrations for doing your database migrations. One other really cool thing about Saturn is that it has the Saturn CLI. So I can do .NET new -i and install the Saturn template, which y'all should go do as soon as fsharpConf is over. And then I can say .NET new Saturn, give it --lang F# and blah, 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 go to the source. And then I get some really cool command line functionality for templating out like really common parts of the application lifecycle. So I can create like a controller, I can create my database access and my migration by using something like .NET Saturn gen.json. This application's about storing Pokemon or working with Pokemon, so that's what that is. But I can like put my keys right here as far as like I have an ID, a number, and a name. And then I can actually run my migrations. And so this is some really nice tooling that somebody maybe coming from like C# or maybe some other completely different paradigm would expect. And Saturn gives that to you in a nice little package. So next up, like I said, we're not going to talk about Azure. So we've done S and A, but now we're going to do Fable. So we can do, with Fable, is write F# for the client. And if you're somebody like me who's really, really bad at client-side development, whether, especially with making things look nice, Fable is something you want to look at. And Fable, oh, first off, JavaScript. This is me trying to do anything in JavaScript. But the way Fable works is basically you're writing F# and you don't really have to think about it after that. But behind the scenes, it's using Webpack and the Fable compiler to generate JavaScript that is usable in pretty much every modern, well, in all modern browsers and some like legacy browsers, for lack of a better word. So you're going from F# through the Fable compiler to AES6 and then using Babel to get that down to ES5. And it lets you create, write F# and emit JavaScript that you can be proud of. If you go to fable.io and click on the REPL, and I think it's in the top left side of this page, you can play with the REPL in the browser and see what some of that JavaScript is going to look like. And I would highly recommend checking that out also. I've been using it a lot lately, and it's made me super productive because I've had to like dig through a bunch of JavaScript docs for things I'm not super familiar with. But and I've had a really great experience. So last thing before we get into some live coding is Elmish, the last part of Safe. Elmish leverages the model view update architecture from Elm. So the idea is I have explicit state defined throughout my app with via messages, and I have an update function that takes a message and makes a small change to the model based on that, and then the view renders whatever the model state is after that update. So it's not just for web apps. And to show that, I'm actually going to pull up a console application that, if I can find it, not that one, that actually shows how to use, how Elmish works at a super high level. So like I said, Elmish is based on Elm, so you have the model view update architecture. In this example, my model is just a record type that has a value or a property for storing an integer. It accepts some input and has some output also. And then these are the messages that will be used inside the update function to update the view. So obviously, since we're talking about a command line app, the view is actually just the standard in and standard out. So our view in this case actually is just going to read from standard in, and then whatever the user puts in is going to be dispatched, which in Elm dispatches what actually sends messages through the application cycle to the update function. So in this case, I read something in, I turned it into an actual message type, and then I dispatch it. And then the update function for each of those message types, whether it's error, increment, decrement, or exit, will mutate, well not actually mutate, but we'll create a copy of the record type with that one change that we wanted, and then that'll get rendered. So if I run this, give that a few seconds. It says enter command of increment, decrement, or exit. So I'm going to say increment to get started. We'll see if hopefully that works. It's 1. We can say it again. And what's happening here is when it says read line, it goes to handle input, which is up here. And basically, if you have increment, it just turns it into that type. If I put in something that's not valid, it lets me know, and then if I exit, it just kills the app. So at a high level, that's really the essence of how Elmish works, is you define some messages. Those messages have a discrete action, result in a discrete change to your application model, and then that gets rendered. And then inside the view, I can, or whatever the case may be, I can dispatch other messages to make a change to the application. Cool. So before we get into our live coding, let's talk about some of the prereqs for using the safe stack. You need to have the .NET Core SDK 2 dot something or 2 dot anything higher than that installed. I think I'm using the preview or one of the previews right now for 2.1. You need Node 8 or higher. I'm pretty sure I'm using 9 something. Yarn or there's some overrides if you want to use NPM. If you're on a Mac or on Linux, you need to have Mono installed, and that's just for the build tooling. At production time, you just need the .NET Core runtime, or ASP.NET Core runtime, I guess. And then for an IDE, if you're using one, I would just say install VS Code with the Ionide extension, and then you're rocking and rolling. You can install the safe template using the .NET SDK also. So I can say .NET new -I safe template, and then I can create one. .NET new safe. Don't forget the --lang f#, and then give it a name and output, and then I can go build it. The template has some pretty cool options. So like we talked about, you have swab draft or Saturn. The default is Saturn, but if you want to change that to one of the other options, you can just do --server. On the client side, since we're using Fable, there's some really cool bindings for Bulma, which is an open source CSS framework. So you can use the Fulma bindings to give yourself some nice styled application without having to do a bunch of extra work. And these are just some of the options. So I can say --Fulma basic, landing hero, and there's a bunch more in the docs. Or you can use whatever framework you want for your how you want to present the application. So for our live coding demo, I actually already have this started. So in this case, I said .NET new safe --lang f#, and I'm using the basic Fulma template. If you're on Mac or Linux and you want to run the build script, you need to give it execute permission first, and then you can run it. But I've already done that, so if we switch applications, I don't need you anymore. Don't need this one anymore. All right, so we have, like I said, this has already been spun up, and I've made a few minor tweaks to it just for the sake of the presentation. But we get up here. This is my the client side. I've got a basic model going. If you remember from our Elmish example, this isn't a whole lot different. I only have one message type right now, and that's just because we're just going to initialize the app. And then I have just a function that represents the actual initial state, which you have to pass your initial state to Elmish to get it started. In this case, obviously, at some point, loading will be true when we start, but it's not yet. And hopefully, we don't have an error as soon as we start. With me, that's probably true, though, also. And then I have my view stuff here. In this case, we're actually using React. So this can take a little bit of getting used to, but if you think about what's going on here, the syntax here is basically, for most of these, let's find a good example. When you think about HTML elements, I have a function that takes basically a list of HTML attributes as the first argument, and then it takes a bunch of child elements as a second argument, and that's also a list. So when I read through this, I can reason about it as I have a div that has a navigation bar, and I don't really have to care what that is. It's just basically a pure React component. And then I have a container element that has some other things in it. I have a thing that says content goes here, and then a footer. And then down here is just setting up the actual app to run. So let's take a look at what that looks like real quick. So you probably already guessed this from the other earlier slides, but we're going to wrap an API to prevent a nice user experience to our users. And so we're going to look at the Pokemon API and f#, and so we're going to catch them all safely. As you can see, content goes here. If we go back to our code right now, we have content goes here. I already have this running in the background. And what's really cool about the safe stack is as soon as I run it, I have the Webpack dev server recompiling and hot reloading the client code as I change it. And on the back end, I can use .NET watch run to recompile the server as I change code, which means I don't have to spend time waiting for the app to build or for Webpack to finish bundling up my app to see what a change looks like. And to sort of demonstrate that, we're going to go from safe template to fsharpConf 2018. We go back to the client. We're going to wait a few seconds. Bam, I didn't have to change anything. And that's just on the client side. We're about to make a bunch of server-side changes. So like I said, we're going to wrap an existing API. And to do that, I've already created some boilerplate code using the F# type providers for JSON. So I have a couple of endpoints that I'm wrapping up here and creating some types for it. And I have some little helper functions to actually get data from those. And then it's getting mapped to a shared type, which if we look at shared, inside of shared, I've got a couple types that are actually being used on both the client and the server. So if I go to client fsproj, I can see this is being shared on the client. And also, if I go to server fsproj, it's being shared on the server. So I kind of mentioned earlier about like pragmatic code reuse. A common use case, at least one that I would use, would be I'm going to have some sort of response from the server, and I have to model that on the client anyway to serialize it or deserialize it. So this is a really great use case for that shared code is whatever the response type is going to be, I can model that on the client, so I have to write that code twice. And we're going to do exactly that here. So first steps here, maybe my client should actually do something more useful than just say some content here. So I'm going to cheat and go over to my snippets. And we're going to start on the server, though. So I'm actually going to create a Saturn controller. And I already did this because I don't trust myself to do it from scratch. So I go into my Saturn controllers. I add this. I'm actually just calling the API wrapper. We're going to kind of break down again what a controller actually is. So I have an index action, and it's under the hood, it's actually just calling that API wrapper. If that wrapper returns success, we're just going to pass that on to the request or to the response. And if it's not, we're going to raise an exception. And then down here, I actually create my controller. So I use a computation expression to set this up, and it's basically going to handle all the routing for me. So in this use case, index is actually a GET request. It doesn't take any arguments. So down here, by default, I just give it a index says, give me a handler that takes an HTTP context and then returns an HTTP func, and that's exactly what's happening up here. So I have that set up. So I need to go wire that up on the server. You can see it's already rebuilding the server after I hit save. So on the server, in my server code, I need to make sure that those requests actually get forwarded. So we're going to create a API router using the scope computation expression back on the server. So go over here. And then I'm going to include that in my main router. So now I can say forward anything that's, doesn't have a path or whatever. So it's just going to like the IP address, and the port is going to serve the static HTML. But if I want to go anything to the API, I'm going to say forward API, and I'm going to say API router. Save that, rebuild, and it should, in a second, tell me everything's OK. And we can actually test that here. It says application started. So if I say send in a few seconds, I should get something back, and I did. Cool. So that covers updating the server. We already saw that rebuilt. I was able to test it immediately without having to actually hit build or anything. So now we got to do some client-side work. Let's see. So we need to update our client-side model. Right now, we're just going to add some results to it. So go back to the client, go to our model record type, new line. Cool. And that broke the init because I'm missing a property definition. We're going to say by default we don't have any results because we haven't made an API call yet. So we're good there, except that needs to be an equals, and that's why I should have used the snippet. And that's good on that side. We need to add some new message types to deal with actually making the request. So the way this is going to work is init is going to kick off a fetch using Fable's fetch wrapper for the client-side fetch API. And then once that promise is resolved, that's going to trigger another message to actually update the model with the result of that response. So oops, don't need the top one anymore. Get rid of that. So now I've updated my init, but I actually need to change a couple more things. Let's see. So before we fix those compiler errors, let's talk about what fetch actually looks like. So come up here. Fetch is pretty cool because it basically just, I did this last time too. It uses a promise computation expression, so I'm able to work with it in a way that's very familiar if you're used to using like the task computation expression or the async computation expression without having to like do a bunch of chaining. So in this case, I define my request property. So this is a get content types application JSON. And then I just say fetch.fetchAs. This is the expected type I should get back. And then I match on it to get a response back. And again, what's really cool about this is like this is pretty natural F# code to write. And this is going to get compiled down to JavaScript at some point. So now the init command isn't actually not doing anything. It's going to kick off our loading the client with data for us to start using. So it's we're going to update init command from before it was command.none. Now it's a command of a promise. I give it the function to call, some extra arguments to the function. In this case, there aren't any. And then I give it an argument for what to happen if the request is successful, and a command for if the request is not successful. So if it's successful, we're going to call the load list message, which accepts a Pokemon list. If it's not, we're going to call load error of exception. So we're going to we're going to dispatch an exception. Now I need to update my update to actually handle those new messages. We already did that. So let's go over here and add some new code to our update. What I like about the update statement is it's just pattern matching. There's not any like major magic going on here. So let's kind of break this down a little bit. This match expression is going to return our updated model and a subsequent command to call if any. As you can see here, most of the time there is not a subsequent command to call. So in this case, on the init, we say if it's OK, we're going to do the load list command. On the load list side, we can say we're going to get back a Pokemon list if we got to this point. And so we create a new record type by copying the old one. And then we just set the results to that list. And we say loading equals false. Now, if we actually want to see that, though, we probably should add replace our code down here where it says content goes here with some actual content. So I have a little function for rendering that out. We're going to throw that right here. And most of these functions, kind of for the view, kind of follow the same pattern, and they take in like a model and a dispatch function. If the view that's being rendered doesn't actually trigger or need to dispatch any messages, you can forego the dispatch part. In this case, I'm not using dispatch yet, but we will very soon. And then I'm going to sort of create like a wrapper content function that will cover all of our use cases for a second. So awesome. So in this case, as soon as I hit save again, it's recompiling even though I'm not quite ready. So now we need to replace our str content goes here with Pokemon content model dispatch. Sweet. So now if I go back here, I have content. So what did we just do? We added a controller. We added a couple message types to deal with loading on the initial load of the app. We updated the model to represent the new things that we added. I don't think I need that, but and then we added some new view code to render those things that were happening. So we've kind of got something here that works, but like, you don't know anything from it, and I'm guessing a lot of people don't know what any of these actually mean. They're just words and not even real words. So why don't we add some more context? Like if we click on one of these, we should see some information about what this thing is. And this will give us a chance to use one of those dispatch functions. So we're going to start on the server again. First, we're going to add a new controller function, which will be our show action. And so following like traditional MVC terminology, show takes in like a single parameter, and it's a GET request, and then returns a single instance of something. So that's what we're going to do here. So we go into our controller again. We add another function. This is the show action one. It's again just calling that API wrapper, which is using the JSON type provider. And the model is fairly similar to what we did above. There's probably some abstraction that could have happened here, but we'll deal with that later. And then I want to wire that up into my controller, so I can say for show, use show action. One thing that's important to point out here is I don't actually need, these functions could be named anything that get past index and show. I'm just using them that way for consistency. So now I've actually already wired up the controller, and now that it's listening to me, I can go test that real fast. I think most people know who Pikachu is, so let's try that. And it's OK. So cool. So now we can wire up the client to actually make use of that. All right, so we're going to follow that same pattern we did before. I need to write a function that is basically just calling the fetch API, and which is in turn calling my API, and then deserializing the response. So let's go add that function. We may as well just put it right after the one that we just copied in. This is, instead of load initial list, this is load a Pokemon, and somehow I still forgot the curly brace. So there's not anything that's super different here from the previous one. Probably another great example of an abstraction that we could work on. But we're, again, just calling the fetch API. We expect a Pokemon response this time and not just a list. And now we need to create some new messages to deal with it. We can also have create our function that returns the command that we need for creating that, or for doing that fetch. So we can go do that down here. I'm going to, just for consistency's sake, or maybe not, I'm just going to put it right after it. And right now I have an error because I have two message types that are at least one message type that doesn't exist. And I get a super fun red error for that. So first we're going to update our model. Now instead of just results, I need to know what ID or name I'm going to get back. So I need to have a command to, or I need to keep that in my application state so that I can use it somewhere. So we're going to update our model one last time, and it's going to have two extra pieces of data. So there's the idea of search text, which is the thing that I need to go get from the API. And then there needs to be a way to indicate that something's been selected so that we can show it, and then also change it based on like what the user clicks on. So now the model is updated again. If we go down, our init function is going to be upset because we haven't defined those properties yet. So let's add those. Selected Pokemon equals none. And search text equals empty string. And that's fine. So now we need to just go back in and add those new message types. So we actually have three of them. We have the clicked event, we have a loading event, and we have a loaded, or not events, messages, but kind of similar ideas. So let's go pop those in. Awesome. Now that red's all gone away. The problem is, though, my update function doesn't actually do anything with those messages. So we should update the update function. And we're going to do that right here. We got load list. So really, we just need these two. I think we'll try that one. Let's see. Update is somewhere. There it is. Add those in. Let's actually line everything up like it's supposed to be. So now on clicked, we're going to say, we're going to call the load Pokemon command. On Pokemon loaded, we should update the model with the thing that was returned. And we also need to update the view one last time to deal with that. So we're going to add one more function in here to show the thingy that we're going to display. And we're going to throw that in here right after results column. And we need to actually use that. So we can say results column. And that's going to be model and dispatch. And one last thing that we have to do is up here, we need to comment this out. That's actually not right. Selected Pokemon. We already did results. My bad. Sweet. And it's compiled successfully. And if we go look at our view, now if I click on one, something bad happened. Cool. And we know that it works when I do that. So let's go look at one thing real fast. Async load, name. Let's see. Yeah, so this is case sensitive, so we need to fix this so that it actually is lowercase. So we're going to do this real fast, and I'm glad I remembered that this was a thing. Dot to lower. Save that. Let it run. Let's see. It's good to go. Let's try that one more time. Boom. So now I have on the right, if I click on any single one of these, that model we created that talks about the selected Pokemon will actually change. We can pull that up and watch in the debugger. Ignore the WebSocket errors. I don't know why those happen. But I can see, oh, something bad happened. Cool, we saw that. But I'm not worried about that one. So we can also say, I click on Charizard, I get a new message. Looks like the problem right now is I'm never updating the error text, but that's really okay. So that's actually a bug I can fix in my application state. But you can see every time I say new message, Pokemon clicked, Charizard, that actually is making the API call. And then we update the state, loading is true. We have some error text that needs to be fixed later. Search text is that. If we look at this one, actually, though, the selected Pokemon should be the previous one. Sweet, it is. It's right here. And then we get the new message that was loaded, and we can see that the selected one is now this guy right here. So we can sort of keep track of what's happening. And there's some tools that will actually let you go back in time and replay messages backwards and forwards. So that's the end of the live coding part. There's a few other things we could do, but we don't have a huge amount of time. So the main things I wanted to point out from that was I never had to rebuild the application. Even when I had a bug, I could just go make the change to it. And if I didn't want to deal with the UI part yet, I also want to make sure things worked, I could use Postman to make a request to it to make sure that I'd fixed whatever the problem was. And then on the client side, I had a similar experience. So to go back to our slides for a second, the only parts, like I said, that I didn't that I did beforehand was actually this API wrapper to sort of save us some time. Type providers aren't really part of the safe stack, although obviously they could be because they make you really productive when you're dealing with other APIs. I really just wanted to deal with the client and the controller to show how Saturn works and how Fable and Elmish work. So cool. There's another flag you can include inside of the safe template. So if I say .NET new safe, I can include -- Docker, and it will actually add the steps to your build script to create a Docker image and push that somewhere. And then you can use, like I said, whatever cloud provider you want, and it just works. And I don't think I have anything else. So I hope that in this almost 45 minutes, I've sort of demonstrated that the safe stack can make you really productive, that you're using F# on the server and on the client. Elmish can help you really track down bugs and manage your application state pretty well. We found one while we were looking at it. There's a couple other things that I didn't talk about, but on the server, or for our not on the server, but for the app, we're managing our dependencies using something called Packet instead of just regular NuGet packages. So if I go look for we're just looking at the client project. Yeah, I don't have any package references in here. Instead, I have a reference to the restore targets for Packet, and then at the and then I have a packet references file which explicitly defines the things that I'm depending on. And what's really cool about this is I get to see if I look at the packet.lock, well, there's a few things, but if I look at packet.lock, I can see what all of my client-side dependencies are all the way down, not just the things that I explicitly depend on, but also the transitive dependencies for those, which is really powerful. It also makes for repeatable builds in a actually repeatable way. So I would highly recommend looking at that. Packet also has has a CLI, obviously, and it has a command called convert from NuGet. So if you are using either project references or package references or packages config, you can convert those over using packets convert from NuGet, and it works really, really well. So, and then my build script is using fake. So if I go to build fsx, it's pretty simple as far as fake scripts go. The key part to it is probably the run command, which is calling .NET watch run. It's kicking off the Webpack dev server for Fable, and then it's opening my browser. And let's see. There's a bunch of resources. Like I said, I'm going to tweet the slides out. The SafeStack docs are great. Compositional IT just did a Safe Dojo app. It's on GitHub, and it walks you through a really great example of creating a SafeStack application. And then I have links to the docs for Saturn, Fable, Elmish, and Fulma. Like I said, I'll have the slides out later. Thank you for your time, and y'all have a great afternoon.
Thank you so much, Jeremy.
Thank you, Tomas.
Let me check. Is my sound OK? Yep. So I did get a few questions here. Just one question from someone in the audience asking about the giraffe and the suave choices. So what are the trade-offs? There was sort of a talk about that as well.
Yeah, I think the best, as far as trade-offs go, like, you know, with respect to Suave and Giraffe, I think if it's just like an F# team and they're comfortable with it, there's not, I mean, Giraffe or Suave is probably fine. I would probably favor Giraffe personally over Suave because it's running on Kestrel and I really like that. But Suave is equally fine, and I've published apps to Azure using Suave also. I like Saturn because for like my teammates where we're working on projects, I can explain concepts in a way that's more relatable, and then as we need to do more complicated things, we can pull out some of the draft functionality to really dig into web requests. And that's the best way I could describe it.
Sounds good. Let me check if there's anything else. I think that's the questions we've got.
Okay, cool.
So
thank you so much.
Thanks very much for coming, driving all the way to here.
All 3 hours.
All 3 hours. Well, see, for someone from Europe, that's
it's a few countries.
Yeah,
right?
it's a few countries. So thanks again for coming. And if you're watching us live, stay tuned. We'll continue in a minute with a Q&A session with Reed from the F# Software Foundation.
Thank you so much.